In this lesson, we're going to take a look at OSPF neighbors on Arista switches. Leveraging the same lab of 5 Arista switches, we'll look at some OSPF commands that are specific to our neighbor relationships. The first thing I like to do is in router OSPF configuration mode, I like to enable detail logging of any changes to my OSPF relationships. If we take a look at the output of show run section OSPF and hit enter, it would seem as though I don't have any neighbor logging enabled, but the good people at Arista know that logging those adjacency changes are important. So if we reissue that command, but ask for defaults by using the all keyword, we'll see something a little different. And I'm going to focus directly on the router OSPF configuration section. So we'll issue the command show run all section OSPF pipe begin router OSPF1 and hit enter. And here in this output, you can see log adjacency changes is already enabled for us by default. But there is an option to ask for more logging data. If we type config router OSPF1 enter and then log dash adjacency changes question mark, we see there's a detail keyword that we can add. And since this is a lab, I'm going to enable that option just to be nosy. Recall from your general OSPF studies that there are certain fields in the OSPF hello packets that must match for 2 devices to become neighbors. Elements such as the subnet, the area ID, authentication, and our hello and dead timers are examples of things that must match in our OSPF hello packets. So let's change the timers on one of our interfaces to be a little more aggressive than the default of a hello at 10 seconds and the dead timer of 40 seconds. So if we issue the command show IP OSPF interface, we can see our hello on both Ethernet 3 and Ethernet 4 is 10 and the dead interval is 40. These are our defaults. So if we go into interface Ethernet 3, we can issue the command IP OSPF and then question mark and see that we have a lot of options to enable at the interface level. So let's type IP OSPF hello dash interval and then question mark, and we can see our range is from 1 to 8,192 seconds. So let's change the hello interval to every 2 seconds on this interface. We'll verify our change with the show run interface Ethernet 3, enter. And in that output there, you can see IP OSPF hello dash interval 2. We can also issue the command show IP OSPF interface, enter, and we can see now that under interface Ethernet 3, our hello interval is 2, and our dead interval is still at the default of 40. We can also issue the command show IP OSPF neighbor, enter, and here we see that we're down to 1 neighbor, where previously we had 2. We're only neighbored up with switch 4. Switch 3 is no longer a neighbor. We can see what our log data has to say about that. If we issue the command show logging and then pipe that to grep -I to ignore case and type OSPF and hit enter, we can see in the output where we received an invalid hello packet and the output specific enough to tell us that we received a hello of 10, but a configured hello interval of 2. So it's nice to get the specific reason as to why we lost that neighbor. So let's go ahead and update the dead interval to be a more aggressive time as well. And then we'll remediate switch 3 with the same timers to get our OSPF relationship back. So we're still in interface Ethernet 3 configuration mode. We'll type IP OSPF dead dash interval. And since our default was 4 times the hello, I'll match that here by using 8 and enter. And then verification with show run interface Ethernet 3, enter. And we can see our OSPF dead dash interval of 8 and our hello dash interval of 2. Another way to verify that is with the show IP OSPF interface command, enter. And under Ethernet 3, we see our hello interval at 2 and our dead interval at 8. So now let's jump over to switch 3 and change the timers on interface to switch 1. Arista, enter, and then show run interface Ethernet 3 and show IP OSPF interface. And under Ethernet 3, we still have the hello interval of 10 and a dead interval of 40. So we'll update those. Config, enter, interface Ethernet 3, enter. IP OSPF hello dash interval 2 and IP OSPF dead dash interval 8. Enter. And in verification, show run interface Ethernet 3. We see our dead interval at 8 and our hello interval at 2. We could also use the command show IP OSPF interface. Enter. And under Ethernet 3, our hello 2 and our dead 8. And then show IP OSPF neighbor. Enter. And we can see that we're working on coming up on our OSPF neighbor. Let's switch over to switch 1, show run interface Ethernet 3, and we see our IP OSPF dead interval of 8 and our IP OSPF hello interval of 2, and then issue the command show IP OSPF neighbor, enter, and we can see that we are now back with our neighbor 172.16.0.3, which is switch 3. When it comes to maintenance windows, I like to leverage the option to change the OSPF cost on an interface. While we do have the option to change administrative distance, the administrative distance option is global, where the cost option is much more local to the individual switch and even more specifically to the individual interface. Our OSPF cost is calculated by the auto-cost reference-bandwidth command, and Arista switches use a minimum OSPF cost of 1. If you have large links, such as 100 gig or someday 400 gig, you may need to change that reference. But back to the maintenance window discussion. With maintenance window work, where we just want to steer traffic away from a device that is undergoing maintenance, changing the global reference is overkill and impacts all interfaces. Instead, we can dirty an interface by simply inflating the cost within the specific configuration of the target interface. The command is config, enter, interface Ethernet 3, enter, and then IP OSPF cost and question mark. And we can see we have a range from 1 to 65,535. If I'm doing maintenance and want to drain traffic away from this interface, I like to use a really high cost, like 65,000. That gets me a dirty interface, but also leaves headroom in case I need to make more changes. So I'm going to type in IPOSPF cost 65,000, enter. And then we can verify that with the show run interface Ethernet 3 command. And we can see our IP OSPF cost is now 65,000. We can also see that with the show IP OSPF interface command. And under interface Ethernet 3, our cost of 65,000. Another command relative to the establishment of neighbors is the passive interface default command. This command is configured in router OSPF configuration mode. Router OSPF1, enter, passive interface, and then you can see we can specify a specific interface or default to mean that by default, all of our OSPF interfaces will be put in passive mode. So if we enter passive interface default and then show run section OSPF and enter, we can see now under the output we have a passive interface default. This command is handy in driving down human error and in keeping the neighbor table clean. The driving down human error portion is that in order to run OSPF on an interface, we'll need to add a network statement and then additionally issue the command no passive interface. Now that I've added passive interface default, if we look at our OSPF neighbor table, we'll see that they're gone. So let's do that. Show IP OSPF neighbor, enter, and we have no neighbors. So I need to enter no passive interface Ethernet 3, enter, and no passive interface Ethernet 4, and then enter. And now if I reissue the command show IP OSPF neighbor, we can see that switch 3 is back and switch 4 is working its way back as well. I also mentioned that this command tends to keep our neighbor table clean. By that, I'm referring to those times when we need to advertise our SVIs, or Layer 3 VLAN interfaces, into OSPF. If we have two switches linked together and both running OSPF on the SVI interfaces, then they will neighbor up on every one of those SVIs. You may see 20 OSPF neighbor relationships between the two switches. This is obviously overkill and adds unnecessary workload to OSPF and to the switches in general. So by leveraging the passive interface default command, we won't automatically establish OSPF relationships on each of those SVIs as we announce their network statements in OSPF. And for the interfaces where we do need them to neighbor up, we can simply use the no passive interface command to allow those interfaces to actually speak OSPF. And then just one more time, show IP OSPF neighbor, and we see we're fully neighbored again with switch 3 and switch 4. And with that, we'll wrap up this lesson regarding items related to OSPF neighbors.